Hi, let us learn simultaneous linear differential equations with constant coefficients. So we all know how to solve a simultaneous equations. So here we are going to solve simultaneous linear differential equations. For example, the standard form being f1 of d of x plus f2 of d y equal to phi of t, g1 of d of x plus g2 of dy equal to psi of t. Now, all we need to do to solve is to make the coefficients of one of the variables same and add or subtract it so that we can get rid of one of the variable and solve for the other variable. So if we see this problem, solve the simultaneous equations dx by dt plus 7x minus y equal to 0, dy by dt plus 2x plus 5y equal to 0. So here d by dt, remember in this topic x and y are functions of t. Hence the solution should also be written as a function of t, because we can see that the derivatives are with respect to t. Now d by dt is equal to d. The operator d in this topic is equal to d by dt. Hence we replace it by d plus 7 into x minus y equal to 0. And the next equation d plus 5 into y plus 2x equal to 0. So what we can observe here is that the coefficients of x and y are different. Therefore, we have to make the coefficients of one of the variable the same, and then we have to add or subtract the equations. Now we can multiply equation 1 by d plus 5. That will give us d plus 7 into d plus 5 x minus d plus 5y equal to 0. The second equation, write it as it is in an order with x term first and y term second. So 2x plus d plus 5y equal to 0. So when we add the minus of d plus 5y plus d plus 5y is equal to 0. So this way we have eliminated one of the variable. Now we will solve for the other variable, d plus 7 into d plus 5 plus 2 into x equal to 0. So remove the brackets and simplify. Then we will get d square plus 12d plus 37 into x equal to 0. So from this we can write an auxiliary equation, m square plus 12m plus 37 equal to 0. So we can see that we cannot factorize, hence use the formula and solve. So m is equal to minus 12 plus or minus root 144 minus 4 into 37 by 2. That's equal to minus 12 plus or minus root minus 4 by 2. So root minus 4 is nothing but 2i. 2 is common here in the numerator and 2 by 2 is 1. So m is equal to minus 6 plus or minus I. So when m is equal to minus 6 plus or minus I, it is nothing but imaginary and distinct roots. Therefore, by case 3 of CF, x is equal to, now here we are finding x. Therefore, x is equal to e power alpha t. In place of alpha, we have minus 6 into c1 cos beta t. In place of beta, we have 1. So c1 cos t plus c2 sin t. This is x value. With x, after we find x, we should substitute for x in any one of the equation and find y. So we will take that equation which is convenient to solve. So if we take equation 1, d plus 7 into x minus y is equal to 0. That is dx plus 7x equal to y. So y is equal to dx plus 7x. That is y is equal to d into e power minus 60 c1 cos t plus c2 sin t. This is a product term, so we should use product rule and differentiate. Plus 7 into the x function. So in the next step we will differentiate that function using product rule. hence the solution, and we'll group the terms. Having grouped the terms, the solution will now be y equal to e power minus 60 into 7c1 minus 6c1 cos t. 7c1 minus 6c1 is c1. Similarly, 7c2 minus 6c2 sin t, that is c2 sin t, minus c1 sin t plus c2 cos t. Grouping the coefficients of cos t and sin t, y is equal to e power minus 60 c1 plus c2 cos t minus c1 minus c2 sin t. Now let's see another problem. Dx equal to, solve dx equal to 3x plus 2y, dy plus 5x plus 3y equal to 0. Now group the terms, move all the terms to the left. So d minus 3 into x minus 2y equal to 0. 5x from the second equation, the x term to be written first. That is, we are just writing the equation in an order. First x term, then y term. So 5x plus d plus 3 into y equal to 0. So we'll make one of the coefficients of one of the variable the same, so that we can eliminate it. Therefore, multiply equation 1 by d plus 3 and equation 2 by 2, so that the coefficients of y becomes the same. That will leave us with d minus 3 into d plus 3. So whenever we are multiplying, we have to multiply the whole equation, all the terms of the equation by that term. So d minus 3 into d plus 3x minus 2 into d plus 3y equal to 0. The next one is, we are multiplying by 2. So 10x plus 2 into d plus 3y is equal to 0. Here we are adding the equation to eliminate y. That gives us d square minus 9 plus 10 into x equal to 0. That is d square plus 1 into x equal to 0. Write the auxiliary equation. We'll get m square plus 1 equal to 0. That is m square equal to minus 1. So m is equal to plus or minus I. That is plus or minus root minus 1, which is nothing but I. Therefore, x is equal to, now here roots are imaginary and distinct. So we are going to use case 3 of CF. That gives us x equal to, so alpha term is 0, e power alpha t, 0t, e power 0t is 1. Hence, x is equal to c1 cos t plus c2 sin t. Having got x, we should substitute x value in one of the equations. That will give us y. So we are taking the first equation, d minus 3 into x minus 2y equal to 0. So 2y is equal to dx minus 3x, removing the brackets. That is, y is equal to half into dx. X is c1 cos t plus c2 sin t minus 3x, 3 into c1 cos t plus c2 sin t. That gives us y equal to half into minus c1. Differential of c1 cos t is minus c1 sin t plus c2 cos t minus 3c1 cos t minus 3c2 sin t. Hence, solution is y is equal to half c2 minus 3c1 cos t minus c1 plus 3c2 sin t. Thus, by using simultaneous linear differential equations, we can find the values of x and y as a function of t. Thank you.